Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we'll do a gate bit on regular expressions and finite automata. In our previous classes, we have done some examples and the basics to understand these bits is provided in our previous classes. Based on the assumption you already know the basics, we'll continue the explanation. The link for the playlist is provided in the description below. Coming to today's class, this is the example. This is very little bit difficult to understand, that's why we have chosen this example. The question here is match the following NFAs with the regular expressions they corresponded to. So they have given four regular expressions. These are the expressions P, Q, R and S. These are the four regular finite automata NFAs. They have provided some NFAs. For these NFAs, they have given four outputs. These are the expressions they have provided. We have to match the following. P belongs to one expression, Q belongs to two expression, like that the matching has been provided. Out of this, which one is the answer? That is what we have to understand. We have to output. We have to find the output, matching output. And coming here, it is bit complex to do the solution. So that's why we will explain only for one. Remaining all are similar. With this explanation, you can identify the remaining expressions. So we are using state elimination method. The discussion about state elimination method is provided in our previous classes. Coming to the first example, for P we are going to solve it. This is our P example. See here, this is the initial state. They have not mentioned the state names. That's why we have provided A, B, C names, A, B, C. So in the state elimination, the procedure is initial state. We are having outgoing edge. We are having incoming edge. What we have to do? We have to add a new initial state. We are having multiple final states. We have to add a new final state, make them as non-final states. That is what we have to do in state elimination method. So after changing these modifications, this is the final diagram which we get. This is the final state, this is the initial state, and these are the intermediate states A, B, C, and this is the final diagram. See here, if you want to eliminate A, what's showing here? From Qi to B, we can move using 0. And one more important point you have to remember, from Qi we are moving to A using epsilon moves. From A we are moving to Qf using epsilon moves. Means we can move to Qf using epsilon moves. So the logic starts from epsilon or remaining string, because in the initial state it is accepting epsilon. That's why epsilon or what's the remaining step? That is what we have to identify. If you want to eliminate A, so we are moving to Qi to B using 0. So that's why 0 concatenated with next. And one more thing you have to remember, if you want to remove A, there are some incoming edges to A. From B, 0, 0, 0, 0, 0, 0. If it is repeating, we have to make a self loop on B. These are the concepts which we discussed in our state elimination method. So self loop on B. The diagram which we get after that is 0, 0. From Qi to B, we are moving using 0 because we eliminated the state A. After eliminating state A, this is the diagram which we got. Now try to understand on B. We can take 0, 0, we stay on B. Otherwise, we can, if you want to eliminate B, we can take 0, 0, we stay on B. Otherwise, we move from here to B to 0, 1 star, 1. We again come to B. Means we are having two different types of loops. These 0, 0 or 0, 1 star, 1. This can be repeated any number of times because again we are coming to B. That's why it is written as 0, 0 or 0, 1 star, 1 whole star. This expression can be repeated any number of times. So after eliminating B, this is the expression we got up to here. Okay. And the last point you have to understand, this is very important to understand, coming here, after on B, 0, 0 or 0, 1 star, 1, again we are moving to B. The thing you have to understand, if you are staying on B, we can go this side or we can go this side. By taking zeros, we can go to C. By taking 0, we can go to A. Whenever you move to A, we end up in QF, means this is accepted. Whenever you move to C, this is also end up in QF, because we can move using epsilon moves, but both sides we are having 0. That's why 0, 1 star end up on C, single 0 end up on A, both can be accepted. That's why at the last in our expression 0, 1 star has been written, because 0, 1 star, 1 we are moving to B again, but from B we can move to C using 0, 1 star, or you can take single 0 and move to A. These are the options which we have. Because why we are considering this option and this option? Because on C we can move to QF, on A we can move to QF. So both the options 0, 1 star, 0. So 1 star can be taken. If you move this side, see here the expression is 0, 1 star. If you take 0, 1 star can take epsilon, we will end up in QF. If you move this side 0, 1 star, we end up on C, we are going to QF. That's why the expression is this, epsilon or 0 followed by 0, 0 or 0, 1 star, 1 whole star, 0, 1 star. This is how we write the expression. So this expression is exactly equal to the first one. So P is equal to 1, our output is Q is equal to 2, R is equal to 3, S is equal to 4. Our output is C. This is the output. You do the remaining problems using a P, Q, R, S. Q, R and S, you do it on your own. Similarly, these are very similar. So no need to explain the remaining questions. That's why we are not explaining. If you understand this, why we have written this expression using state elimination method, it's very easy to understand the remaining Q, R and S also. Hope you understand this concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.